Hello guys, welcome back to my channel Fun with Chemistry. Today we will discuss the shapes of various atomic orbitals because I think these are very important for coordination chemistry and for hybridization also. So after completing this atomic orbitals, we will move to hybridization and coordination chemistry. Atomic orbitals are very important for inorganic as well as organic chemistry, and no one will teach you about atomic orbitals directly. They'll teach hybridization and coordination, but that is not the right way. So today we will discuss about the shapes of different atomic orbitals. So without wasting your time, let's get started. So guys, as I told you, today I'll teach you shapes of different orbitals. These are very important, and the whole importance of these different orbitals and their shapes I already explained to you. So starting with s orbital, the first orbital is s orbital. The first thing we should know about s orbital is it is spherical in shape. Spherical shape. Spherical in shape. And before drawing the structure, one thing I'll add in this, I'll take z-axis as internuclear axis. Z-axis as internuclear axis. Internuclear axis means main axis. I'll take z-axis as main axis. Suppose these are the axes. So z I am taking as the main axis. After that, x and y. Okay, so I am taking z-axis as an internuclear axis. The main axis is called the internucleus axis. So s orbital, drawing the s orbital first. As I told you, so it is spherical in shape. So this is the structure of s orbital. As I told you, z-axis is the internuclear axis. So this is s orbital. S orbital. Okay. After s orbital, we have p orbital. In p, as I told you in my first video, px is present. Okay. Py is present and pz is present. Px, py and pz is present. And so I'll draw px, py and pz now. I'll draw px, py and pz now. So px, okay, suppose that I'm taking this axis as x and this is y. So px, in p orbital, the lobes are drawn in the axis. Okay, in the axis I'll draw the lobes. So px I am drawing. This is px, okay, plus and minus. This is px, okay. Similarly, I draw for py. This is now I'm drawing py. Py axis I'm drawing. This is my x and this is my y. Okay, so py I'm drawing because so this is my py. Okay, plus and minus. Now at the end, pz is left. Pz is left. So what I'll do, I took x this axis and y this axis. So now z is this only. So here I'll draw positive, negative. This is our pz. So in p orbital we have three basically: px, py, pz. This is px, this is py, and this is pz. Okay. Now I'll draw for d orbital, which is very important. D orbitals are very important. So now I'll draw for d orbital. So d orbital. For d orbital I'll draw now. In d basically we have 5 name. First one is dxy, second is dyz, then dzx, this fourth and fifth. dx square minus y square and dz square. So these are the names of 5d orbitals: dxy, dyz, dzx, dx square minus y square and dz square. So one by one I'll draw these orbitals. So first I'm drawing dxy. dxy I'll draw. Okay. So this is my x-axis, this is my y-axis. And one thing is very important for d orbitals. As I told you, for p orbitals, lobes you will draw within the axis or in the axis. Okay. Here you will draw the lobes in between the axis. Means these are the axis. Here you will draw. In between you will draw. Okay. So we'll start with dxy. So this is dx and this is dy. Okay, so in general it is dxy plus plus minus minus. This is dxy. Fine. Now second is dyz. Okay, if you will see in competitive exam related books, these diagrams are given there in very large manner, we can say, and very tough also. But as I told you, the choice of taking the axis depends on the chemist. If I am drawing these structures, so the choice I'll choose accordingly. So here for simplification, I am choosing, this is y-axis, this is my y, and this is z-axis. Okay, so how I'll draw the structures: dy and dz, plus plus, negative negative. So in this manner, this is my dyz. Now you will say dxy and dyz are orbitals are entirely same. No, the major difference: this is my x-axis. I changed the axis from x to y. This is my y-axis. This is the difference I'm talking about. These diagram in appearance are looking same, but in general these diagrams are very different because I'm changing the axis also. Okay, if you will see in any competitive exam related book, these diagrams are explained in very tough manner. So this is the simplest way. Similarly, dyz I'll draw now. dyz I'll draw. Sorry, xz I'll draw. So this is x and this is z. dxz I'm drawing. So this is my dx and z. So positive positive, negative negative. That means dxz, dxz or dzx. Both things are same. Okay. Now two are left: dx square minus y square and dz square. So I'll draw the remaining two. I'll draw now. dx square minus y square, very important. dx square minus y square. Now I'll draw dx square minus y square. This is my x, this is my y. Okay, because x square is there and y square is there, so I'll draw these lobes in the axis. This is my dx square minus y square. Positive positive, negative negative. Okay. Now the most important one among d orbital is dyz. The last one, sorry, d. After dx square minus y square, the last one is the dx square minus y square is done now. dz square I'm talking about. dz square, now I'll draw dz square. Okay. Basically, if you'll see in the book, the diagram is given. This type of diagram is given for dz square. But today I'll explain you how you will get this type of diagram. So basically dz square is made up of two type of orbitals. It is made up of two type of orbital. First one is dz square minus y square. Okay, and second is dz square minus x square. It is basically made up of two type of orbitals: dz square minus y square and dz square minus x square. So separately I'll draw both, then I'll combine both the diagram and I'll show you how you will get dz square. So first I'm drawing dz square minus y square. I'll draw this. I'll draw z and y. So I'm taking my internuclear axis. This is y and this is z. Okay, this is y and this is z. So dz square means in between the lobes I'll draw, sorry, within the lobes I'll draw y square and z square, plus negative. This is my d z square minus y square. Similarly, I'll draw z square minus x square. Now this is my y, z, that means x is this, z square means this, z square, x square, this is x now, this is my x square, positive, negative. So it is made up of basically these two structures. Now what I'll do, I'll combine both the structures. That's why I'm writing here. This is dz square minus y square and this is dz square minus x square. Dz square is basically made up of two types of structures, dz square minus y square and dz square minus x square. Now see the common thing here. Dz square is here also and dz square is here also. So this is the common orbital. Dz square is common. Okay, after that we have x square here also. This is my x square. Okay, and then we have z is done, x is done, then we have y also. So in general this diagram looks like this. Okay, so that's why it is written as, in this manner you can write it. Okay, so this is dz square. So in S we have one orbital, in P we have 3, px, py, pz, and in D we have 5, dxy, dyz, dzx, dx square minus y square and dz square. Okay, now the shapes of different atomic orbitals are done. Now in the next video I'll teach you different types of bonds which are present in chemistry. I'm not talking about covalent, ionic and coordinate bond. I'm talking about sigma bonding, pi bonding, delta bonding and psi bonding. I'll show you how sigma bond is formed and why sigma bond is formed. Same goes for pi, delta and phi. So in the next video I'll make a short video on these topics. So thank you so much for watching this video. If you like this video, please like and subscribe to my channel.